Pod countdown. Welcome. Okay. Just letting you know, I did promise you this last week.
42 minutes long. 42 minutes?
All of this month is just too much writing.
Really? Yeah. I mean, well, it's up to you. You don't have to write the notes down. It's just up to you what you want to take from these.
If we don't take notes, it's always on your video, right?
Yeah, it's literally on my video. It's just up to you. So my thing is, if you guys take notes in my class, that's notes for that section,
Yeah.
But if you find it's easier just to write notes from the sections just really quick at home, then go ahead and do it. My only suggestion is to go over this stuff in case, for one, you have trouble with the content, or two, you kind of want to know what I'm going to test you on. That's your benefits. But if you find that you're like, I'm better off just studying on my own, not watching these videos, that's your option to do it. Okay. If you guys grabbed this from last week, get it out now. We're gonna go through, get out your cheat sheet for 5.4.
What food should we make?
5.5. I will review and
What? Can you give us like a hint to what it is?
It's got chicken in it.
Chicken.
Chicken.
I don't smell chicken. I smell like sour cream and cheese and like.
Well, yeah. What I got is advertised as chicken.
Is it pasta? Advertises chicken? Is it
It's
not?
advertised as chicken. It may not actually be chicken. Who knows?
Maybe it's like a chicken, like maybe chicken
Substitute.
ramen. Yeah.
And those are handouts from the previous
Oh my gosh,
section.
there's Catherine. We literally were just
Oh.
like,
Is it pasta or chicken and vegetables?
Okay,
Catherine, we missed you.
Yeah, I was right.
No, we seriously did. We talked about you for like 2 minutes.
Yeah, we actually did the
gossip.
Yeah. No, I didn't. It's like, no, where is she? I don't know.
All good things.
All the one time I don't have my actual TV. I know.
I know.
Where have you been? Not here.
Yeah.
Here.
Oh, is it still recording?
Yeah.
You might have gotten the last.
Okay, so today we are not going to go through 5-4. I'm going to mention it a few times as if we kind of did, because some of the stuff from 5-4 is pretty easy to just get right away, right? So we're going to go on to 5-5 and 5-6 today. Again, I will mention a few theorems you should learn from 5-4, or you will learn today. It's not that difficult. Actually, before we do that, draw me 2 lines somewhere on a piece of paper or on the whiteboard. If you're lazy, you don't want to get out a piece of paper right now. Just draw 2 lines that are kind of not intersecting. Yeah, intersecting each other any way you want.
I got 2 lines somewhere.
You got 2 lines somewhere. Oh, I thought you were looking right at me.
No, right there.
Okay. 2 lines intersecting.
Yeah, when you tell people to like erase their stuff when they're done, we have to do the work of erasing.
Yeah.
Yeah. That's true. You have a kid mentality.
So there's 2 lines.
Just two lines that are intersecting.
They have to be on the screen.
Yeah, try to make them straight too. Yeah.
That's
Oh.
not happening. We're drawing. Wait. I have a better idea. Lucy, that was so straight. It was so curved. There you go. 2 lines
Oh,
that are
right there.
intersecting. 2 lines that are intersecting.
These a little bit farther apart. How about more than 10 degrees apart?
10 degrees.
Apart, yeah. So it can't just be.
How do you
100.
figure out degrees without using a?
Protractor?
Yeah.
Oh, I was gonna ask, do you guys want a protractor? Like to no?
Do we need it? That was my
Might help.
Why do you have protractors and envelopes?
I don't know.
I had
Are they
one
paper?
and it
I
broke
don't know.
in half.
They're actually pretty cool.
What?
I had one and it broke in half.
All right. And with your, so I'm gonna draw a line too as well. And then let's see if I have my. So if you drew your angles or your lines sort of properly, what do you notice between this line or this angle and this angle? How would you describe the relationship between those 2 angles? In fact, look at your angles that you created. Pick a pair of angles that are right across from each other and then analyze what are the measures of those lines. Yes?
They're the same because they're vertical.
I'm not asking for a number, just asking if they're the same.
Yeah.
Right? Okay, and then look at the other pair of, so I would say you don't have to draw this, okay? What about the other pair of angles that are right across from each other.
They should be the same.
If you drew nice straight lines, but that's why I was asking Luciana. Okay, Lucy. How would you? Sorry, I'm like suffocating. Okay, how would you describe? Okay, if you look across, what would you say their angle measures are as well?
The same.
They're still the same. So there's another word for it. So you can indicate that they're congruent by having the congruent or similar in measure by having two dash marks, or maybe a angle kind of like arc with a single dash mark, double dash marks to indicate.
Each one has to be different, like that.
Yeah, so like the point is though, or actually, why is it that I had to indicate that these are different between these two angles? Yeah, we don't know if they're the same or different. So the only ones that are confirmed are the ones across from each other. There is a word for that in Algebra 2 or Integrated Math 2, which we refer to by. It starts with the letter V.
Vertical.
They are considered vertical to each other. So instead of saying the angles that are across from each other, we say the angles that are vertical from each other are always going to be congruent. Okay, so look at your cheat sheets really quick. Look at 5-4. I think it's on there. Yeah, try to locate where I talked about that. Where is that theorem? 5-4 on your cheat sheet, 5-4. It's on, where is it? On the front, the back?
There's a back.
There's a back to this. I got you. I tricked you. Yep, it's 5-4 vertical angles theorem. So literally, I want to go over something that we should know from 5-4. Okay? I'm trying to think of anything else that we need to go over besides that. So it's right here. I'm sorry. So angles that are vertically from each other are always going to be congruent, no matter how you draw it. So I know, let's look at Luciana's. Hers is really tricky, but again, could you argue that her angle here and this angle here are roughly the same? Yes. And how about these huge angles she created over here? Yeah, they're roughly the same if I use a protractor. Okay, very, very good. Okay, so now let's see if we should be good. All right. You and a partner now. Okay, now you and a partner. Again, find a space on the whiteboard. Draw me two lines that are parallel to each other, any which way you like. Two lines that are parallel to each other.
Wait, 5? 2. Wait. I think he means
Any two lines that are parallel to each other.
I kind of want to do it. Just because.
Now I would recommend, hold on, stay up there. Now I would recommend, so Luciana and Ivory, I would suggest you make them a little bit more far apart. It's going to make it pretty difficult what you're about to do.
But they're still parallel. They're technically
They
parallel.
are. Yeah. I'm just saying it
You
might
should have
make
given us specific directions. They were parallel.
All right. You could keep it that way if you'd like. Okay. It's up to you. Okay. Oh, great. No, I like that. Okay.
Parallel.
Okay. Now, if you can, I got two lines that are parallel. I will indicate that by drawing an extra arrow within them. It's not.
We're supposed to draw like that.
No. Don't say, are we supposed to draw like that? You can draw it however you want. Now draw a line going the opposite way that goes across them both. Any way you want, okay? Okay, and then that is what we call a transversal. Anything that cuts two parallel lines across is called a transversal. Label that a transversal. Okay, now number your angles. 1, 2, 3, 4, 5, 6, 7, and 8. However you like, according to your. Okay, now you and your partners get a protractor.
Wow. Wow, we need to.
If you like, you can work with one. How many do you need?
Yeah.
How many do you need? There's one in the Espanol. Tres, dos, uno. You got the order wrong, my friend. Hey, I can do that one. Okay, measure each angle. Please write the angle measure. If you don't know how to use it, I will help you. Okay?
Yeah, you just.
We're good?
You just kind of. What is it?
Do you know how to measure the?
No. This would be.
So here.
This would be. Oh wait, no. Okay.
From here, make that
Wait, what are
zero.
we still
And then see how it opens up. So this opens
Like
up
four
to.
is bigger, I think. Like it's over 90.
Yeah, yours are gonna be the.
4 is 90.
The way you wrote yours, all of them are gonna be the same. Okay, go ahead and put 90. That's fine. No, that's fine. Yeah, it would help to make it a slant. Because you can find differences. So can you make your parallel maybe more slanted? You can do that. I'm just gonna say that we're gonna start to say that congruent to this, and this is congruent to that. The way you have it, everything's good.
Who's checking?
One is
Wait, no, that has to be 130.
So then that means that they're all like
Yeah.
Good for you.
are you writing? I think they just put like one.
Yeah, let me help
Doesn't
you.
really work here, but
You're gonna set this dot
I'll get
to
another.
where like the origin of the angle is. That thing like that zero, you can see how it opens up.
That is a lot of tape.
That is going to be about 60 degrees.
Never guess.
Amazon there's
Yeah, and you don't know where to set it to. You can kind of reset it here, like that. Yeah, and then set that to here.
yeah.
I know, he's gonna make
So-
Should we write all of them or just 1, 2 is probably fine?
Oh, 120.
Well, if this is if it will,
Let me give you a little
yeah, that should
shortcut,
also
too.
be
They make a
100,
straight
and then
line.
that should be 100.
How many
and
of those?
100.
I don't think I ever read the. Do we need to show?
Yeah, so and then here.
Oh, so then you just make grid. Oh.
So you can do some little shortcuts. Guys, there's some shortcuts to this, right? I don't know if you guys have noticed. You guys.
So,
Is this like single book series?
Yeah, 60, let's say 60. Okay, do you want to?
Now it's all red.
Okay. And then how much are this?
It's really good, like you're good.
Arrow 5. So let me show you how to do some different angles. Okay.
I'm pretty sure.
You can reset it again here. 5.
show me like from
Carolyn's Ian and.
Right here, you line up these black lines. Okay?
Yeah.
This goes from 0 and see how it goes up. How much would you say it is? So 100. I say in between this, between these two.
There's a lot of options.
Take that marker.
Let's just say
I would just
the same.
write all my paper, but like
No, so write 150
and
and then erase this. So you know that this 65 compared to this 6.
I would, my books, when I was like.
There might be a shortcut too to this as well. If that's 65, this is a straight line. What are they supposed to do? So how much do you think that one should be?
I love Geronimo.
So is it adding these two or just?
Yeah, do they make a straight line? Yeah, they do, right? So do they add up to 180? 115 plus 65? Great, that means you made good lines, okay? So 65, what do you have to add to 65? What do you have to-
I never got into
We on.
Because they're all written by different authors.
What did you add? to
all in
65?
one series.
So how much did you get that? So let's
I
see.
like, they just start reading like really sick.
whatever forms the
This right.
Yeah.
whatever forms the straight
So
line.
I was in a second third combo.
So this angle, so this straight line opens up like
They
this.
didn't have like smaller books or
So
us
this,
like the
so
really
this is
thicker
65.
books
What
for
is this?
older kids.
This is like
And the thing
That's
was,
not
especially like the older kids were taking
And
like
then how about
thinner
here?
books.
They're vertical.
And I was like the one
Yeah.
for like the really thick books.
Try that on here now.
I have like 1 week every like 2 months.
All right, guys. So I think some of you guys might have used some properties that you already know, right? To save yourself some time, correct? So I'm gonna measure mine really quick. Mine are actually very parallel. My two parallel lines.
They're technically not.
If you believe,
If you believe, if you believe, you can achieve.
If you squint at it real hard, sure.
Yeah, in a way where everything blurs up together. All right, that looks good. Okay. Okay, so if you guys
it's not long. You should have made your line longer.
Yeah, that's why I made mine.
It would have helped.
it would have helped.
Now you have to use a ruler and not.
Now I have to use a ruler in this way. Okay.
I would have been really hard.
Okay, so I know these protractors were a little odd, but I kind of like it. It makes it a little bit more freeing for me. I don't know what it is. Some protractors, you got to kind of manipulate this weird middle plastic piece. This one I like. You just set it equal to the 0 here and see how the angle opens up. So it kind of opens up to about, what would you say? That's about 65 degrees. Okay. Now, I could tell you to do this. All right, let's reset this thing. And let's see, that's 0 and that's about 115. But what could I have done to save some time? What could I say the relationship between, what could I say between the angle of 6 and 8? Yeah? Marwa?
You could just subtract 180 from 65.
Why did you say that? What makes you say that you could subtract 65 from 180?
Because it's a line. And a line.
Do you notice that angles 6 and 8 are part of a line, right? They have to add up to supplementary angles, or they're supplements to each other. So they have to add up to 180. So,
Why are there 2 8s?
No, why are there 2 8s? There should be a 5.
whoopsie daisy. Thank you guys so much. That's a 5.
Maybe that was a 5. We just wrote it.
No, yeah. And then this is a 115. How about, let's use some other things. What about, do you guys see any vertical angles that can help save some time? What is vertical to angle 6?
7.
So that would make that 65 degrees. Okay. What about, how about any relationship between 7 and 8? They're 180. Okay. Oh, wait. Yeah. So that's 180. So I could subtract 65 from 180. Or I could have just seen that these are 2 vertical angles as well, right? Then I went over here and, okay, let's just assume I made perfectly. All right, that's okay. Oh, I'm going to lie a little bit. I'm sorry. That's 65 degrees. Okay. Let's just say if they're parallel, you should have found that both of these angles should have been the same. This is 115 degrees. And you're going to find the same exact relationships over here as long as both those lines you made are parallel, right? They're cut by any transversal. You saw it did not matter. It looks like from the looks of it, most of the parallel lines cut by transversals that you all made differently exerted the same behaviors, right? Do you see any similarities between these set of angles and these set of angles as well? Okay, so let's make a relationship in my picture, right? And you can connect it to yours. What would you say is the angle that looks most like this first angle here in this set? So let's make this separate from these set of angles. But if I had to compare this set to this set over here, which angles most look like angle 1?
5.
Yeah, I would say 1. Okay, so in your cheat sheet,
5. Like, yeah, that's
angle 5. Sorry.
Yes, angle 1. Like angle 1.
Which is the symmetric property. Yes, so that works too. They named theirs a little bit differently, but what would angle 1 and angle 5 be known as if they looked exactly the same? They were sort of in similar positions. These are what we call corresponding angles. If you have 2 parallel lines, they're cut by transversal, and you make sort of like a set of 4 angles with those parallel lines, you find what we call corresponding pairs. In this case, 1 is corresponding to 3, okay? What else is corresponding? How about the corresponding angle to angle 2 over here? Okay, do you have corresponding angles in yours as well? So on, let's say Sophia's. Okay, I know this is really tricky here. It's a little tricky because like I didn't tell you how big you should write it. What does that say right there, Sophia? 7. Okay, and this set of angles, what is corresponding to angle 7 on this set here? Angle 1. Okay, very good. Okay. And let's see. So I'm not going to go on, but you guys can see there's corresponding pairs, and they're both equal in measure, right? Okay. So that happens when you have two parallel lines cut by transversal. There are other things too as well. Besides 1 and 5, let's make more comparisons to 1. What else is congruent from here to angle 1 on this set? 8. And they are sort of on the outskirts, right? On the outside. How about angle 6 or how about just angle 6? I'm sorry. Are there any corresponding angles or are there any angles on here that share the same measure? 2 and 3. So 2 and 6 are what angles to each other? They're corresponding. 3 though, because 2 is vertical to 3, they're the same, and then that makes 6 the same, right? Does anybody know the name of those two angles and their relation to each other? You are very, very inquisitive, young lady. Okay. They are what we call alternate exterior angles. So if you drew yours right, okay, your angle on the outside of the parallel lines, depending on how you drew it, like 6 and 8, these two, because they're alternating, they're sort of like, they're kind of alternating like up, down, and up and down, okay, from the transversal. They're alternating, and they're also on the outsides, okay? How about angle 5 on this picture? Who should he be congruent to? That is exterior out here. 7. Very good, okay? How about the guys on the interior? So we call 1 and 3 and 6 and 8 on the interior. Or the exterior? What about the interior? What about angle 2? My angle 2 is congruent to who? To 7, okay. And then 5 is congruent to who? 4 on the other guy. And because they're I guess let's see. Yeah. I guess this is up and down too, but I think they call this something a little bit differently. They are interior angles, and they are also congruent to each other. But I guess they call this consecutive. Why? I think I made a mistake in the way I explained it. But why is it that this is consecutive and this is alternate?
Because consecutive means that they're like right next to each other, and alternate means like they're opposite from each other. Like.
Okay, I see what you're saying. So like here, 1 and 3, it's just like, it seems like it's one after the other. I guess here, it seems like there's like a middle space here that they skip before they get to the guy that they're congruent to. Does that make sense? I guess that's why they call it alternating, because it's anybody. Yeah, Sophia, what do you got?
It is alternate interior. It's the one.
It's backwards.
1 and 2 are consecutive.
Oh shoot. Okay, I'm sorry about that, guys. Okay, so I was kind of getting a read on Miss Rizzo's face. That's why you made that face now. I see now. Okay, I do apologize. So oops. Okay, so this is an alternate. Don't draw that, okay? This is alternating from up and down. So these are alternating interior angles, and they are congruent. Alternating exterior angles is the same case. 5 and 7, they're just on the outside, are congruent, as 6 and 8 are. Then I guess let's take a look at this then.
At the angry face?
At the angry face one, yes.
Oh, that's just saying like 1 and 2.
Okay.
So what it means is that like it's literally the one like straight across.
Are you supposed to know these terms?
Those are supplementary.
So yeah, because if you guys look at yours really quick, look to see if yours add up to 180 as well. Do your consecutive interior angles, the angles that are right after each other, not alternating, but right next to each other, do they add up to 180? If they are, you have constructed good parallel lines with a transversal. If they aren't, it's okay. you did well, okay, in constructing it, or maybe you were super, super, super accurate with your protracting skills, okay? But if they're roughly adding up to 180, you did a good job, okay? So consecutive here, 3 and 4 should have added to 180, and 2 and 3 should have added to 180, okay? What if I did this? So I saw Katrina and Catherine's paper. They did this. Let's name this again. 1, 2, 3, 4, 5, 6, and 7, 8. What if angle 6 was equal to 90 degrees? What other angles are congruent to angle 6? Yeah? Pretty much, yeah. You can start going ballistic here. Well, if I use the alternate exterior angles, then these should be 90 degrees. Wait a minute. What else can we say? Yeah, consecutive. Oh, vertical. Okay, so 2 and 3 are also vertical or 90 degrees. What else? Okay, they are 7 and 2. Well, what do we call that then?
No, 7 and 6.
7 and 6 are vertical. Okay, what else can we say? How about what makes 2 and 7 congruent to each other? Okay, and then how about what about 2 and 4? How much do they add up to? Oh, I'm sorry. Oh, no. 2 and 5 is what I wanted to focus on. Yeah, they are consecutive interiors, so they add up to 180. But if that's 90, that has to be 90.
And then alternate interior makes 4, and then vertical makes 1, and
4, right?
And then 5 for 8, and then 3 for 2.
3 for 2. Okay, so this one, the very on the bottom, it's the perpendicular transversal theorem, which says in a plane, if a line is perpendicular to one of the parallel lines, then it is perpendicular to all. In this case, everything is 90 degrees. Okay, so that's why I didn't want you two to do that, or else you'd be making you'd think that every angle is the same as long as you make parallel lines. That might be okay, guys. Everybody got this down so far? I think this is one of the trickiest things to learn, but you guys actually intuitively understand it better than I think most people do now. Okay, let's go over an example now. Okay, so let's label this 5-5, Luciana.
Sure.
Yeah, I am very sure this time. Okay. Angles and parallel lines.
Are you sure that's what it's called?
I'm not sure about this part, but I'm doing my best. Okay.
Are we taking notes or just an example?
We're gonna do an example now.
On the board?
Do you want to do it on the board?
I don't care.
Okay. All right. We're gonna use
It's up to you.
corresponding angles. That is your clue. Do you want me to show you how to do it, or do you want to try it on your own first? Okay, and then I'm going to label this 1, 2, 3, and 4, 8, 7, 5, and 6. The measure of angle 5, okay, you're given that the measure of angle 5 is equal to 72. Okay. I want you to find, let's see. Okay, so let me do the first one really quick. I want you to find the measure of angle 4. And only given what we have so far, what do you think the measure of angle 4 should be? How would you know that the measure of angle 4 is 72 as well? A theorem, okay.
Wait, so for number 4, alternate interior.
Are you sure?
No, wait, no. That's 7. So for 5, well, it would be corresponding.
Okay. 4 and 5. So this is like a set of 4 angles. This is a set of 4 angles. 4 is corresponding to the 5th angle here. So we would say the measure of angle 4 is congruent to the measure of angle 5. And then we'll just say on the side that that's because we know that's corresponding angles. That's a postulate. then you'd say the measure of angle 4 is equal to the measure of angle 5. Because if we know if they're congruent, they're equal. So that is just the definition of congruence, or just congruence. And then if we know the measure of angle 5 is 72, we can substitute that, but which makes angle 4 and 5 equal to each other from the second statement. We'd say that is, we'll just keep it as measure of angle 4 to explicitly say that. We use substitution, okay? I want you to do the same thing I just did, but for angle 2 when you determine what angle 2 is, okay? All right, guys. So find a space on the whiteboard now, and then go ahead and try this out. I want to see what. You do not have to draw it. No, you can go off the drawing that I have. Example number 3. Yes.
So, 2, 4, 3, 5, 6, 7, 7, but you did 5, 6. Does it matter which order?
No, it really doesn't. Yeah. But I just want to see if I actually copied it down right. Or else I would. Yeah, it's actually done like that in the book.
What angles do you want?
I want you to find out the measure of angle 2. You can call upon older the ones from 5-4 as well to help you.
We know what it is, but we don't know how to explain it. We don't know how to write it.
Let me go over and see what you guys got so far. Okay, let's see what you guys got.
We're making it fun for you to read, Mr. Reed.
Oh. Okay, so if just imagine this set now is corresponding to this set. So you said 2 and 7 are alike. We use terms to say they're alike. Correspond. So that these corresponding angles. 2 corresponds to 7. You see that? Do you see the 2 parallel lines here? These 2 parallel lines, they're cut by any transversal. And you can make relationships between them. 1 looks a lot like 8.
Yeah, that's how I had it. I had to switch
2 looks a lot like 2. Or 4 looks a lot like 2. 5. So they're corresponding. 3 looks a lot like 6. So they're corresponding. Does that make sense? And then how to explain that? You justify that by using corresponding logic. It's like don't cross the street because there's a law called it says don't cross the street.
This was yesterday.
What that says is you'll watch it.
Okay, so switch the 5 to a 7.
Yeah.
Then on the side, just put corresponding A's.
Awesome. Very good. What would use actually the exterior angles? Angle 5 and 2. Oh, yeah, that works too. Yeah. You're welcome. It's especially made for you. You traveled 29 years to get in your hands. Go back and you traveled this far. So you said 2 and 4 are okay. So 2 and 4 are right across from each other. So corresponding means that like you see 1, 2, 3, 4. It's 7, 8, 7, 5, 6. That'd be when you're comparing the beginning of that set to the bottom of this set. So like 1 looks a lot like 2. So that would be the corresponding. They would be the corresponding. Who would be corresponding? So they're vertical. 2 and 4 are vertical.
No, but remember how we had that they were like real.
So you guys actually came up with a lot of good different ones too. Everyone came up with Actually, in the meantime, Sierra's group, can you guys describe how you guys solved this? You guys did differently from how I did. So everyone pay attention to Sierra's group. So it could be Marawa, Sierra, and Medea, what's your name again? Skylar. Skylar.
Well, you could also do it like this.
I know. I want to hear what they had to say. Give them a second. Indigo, sorry, Indigo. Anybody want to get up and? Indigo, you look fired up. Why don't you go ahead?
I know.
Yeah, get on up there. Yeah, don't worry. Yeah. We're just speaking to like. Nice.
Well, 2 and 7.
But
2 and 7 are corresponding.
can you point them out to us? We need sentences. 2 and 7 are corresponding. Okay.
An angle. So we can, by definition of congruence, m angle 2 is equal to m angle 7, and then we can substitute, and we get m angle 2 is equal to 72.
Okay, and then, but did I say angle 7 was 72? I just realized this. Was angle 7 equal to 72? However, what can we make that relationship? Yours is still right, Indigo. But Katrina, go ahead.
5 and 7, since they're vertical, so then you can do 2 and
So you just need to add that in there, like maybe after congruence. Very, very good.
How do you
Great.
say something's vertical? How do you write that?
Just vertical angle.
Want to know what you could also do?
You would just say angle 5 is congruent to angle 7. That's
Oh, okay.
right? You just say that. Oh, guys, also don't model yourselves after bad behavior. We also need to specify the unit. What is the unit of 72? It's just degree. Okay, Luciana, do you?
I think that's what she did. She used vertical angles by using the angle of 4, because they're vertical angles.
So okay, so everybody
we know
look.
that 4 is equal to 5, so that way we know that 2 is equal to 5 because it's a vertical.
All right, so you're out. No. Okay, thank you. You didn't even let me have a chance to thank you first. But yeah, we determined earlier 4 and 5 are corresponding, so they're already congruent to each other. But then who is vertical to 4? 2. So Sophia was just like, I'm not gonna do any more work. Okay, so that's ridiculous. Okay, because he already did most of the work up here. 4 and 5 are corresponding; they're equal. Then I also know that these two are vertical, so that would just make angle 2 equal to 72. Okay. Sorry. Right. So I rewrote it again. 2 and 4 are vertical. That means that also 4 and 5 are corresponding. That makes, but we also know that because 4 and 5 are equal to each other, and 2 and 4 were equal to each other, what does that make 2 and 5?
Equal to each other.
Yeah, or congruent. I'm sorry. Yeah,
Oh,
congruent.
congruent to
Sorry.
each
Sorry.
other.
So that's a transitive property. Okay. Like if one thing is equal to, like A is equal to B, and C is equal to B, that makes A and C equal to each other. That's what we call the transitive property. And then if we know they're congruent, they're also equal to each other, and then we can finally substitute in the actual value of 72. Any questions so far?
For the test, we'll have the cheat sheet, right?
Yeah, you'll have all these cheat sheets, but hold on. For the test, you got to bring in your own cheat sheets. I got to check, no writing on it. Okay, so if you're gonna make any writing on it or anything, keep note that you're not gonna be able to use it if you put any writing on it. And also, please don't lose them, because a lot of times, I'm not gonna lie, I just barely print out the exam all right in class, like, right? And I put them down, like, all right, who's ready for the test? And they're like, do we have cheat sheets? And I'll be like, no, you should have brought it. The truth is, I forgot to put them in, okay? So print out your own, just for your own safety, in case I don't print any extra ones, okay? And you can use them on the test.
You're the best.
Yes. No.
He's like, yes, I know I'm the best.
Well, no, just kidding. Okay. Example. What are we gonna do now? All right. Here's another problem. But that's good though. There's a strength to memorizing these, so you just know them.
Is it still 5-5?
This is still 5-5. This is going to be one last problem then, okay? And then we'll go on to 5-6, which is eerily similar to 5-5. If you understand these concepts, you should have no trouble understanding the other concepts from 5-6. They're actually very, very similar to each other. Find the values of variables. So now we're going to integrate more math, like with variables in here. Uh-oh, how is this going to mix?
Oh, okay.
This is still within 5-5 if the measure of angle 4 is equal to 2x minus 17 and measure of angle 1 is equal to 85. You must find x and you must explain your steps as well.
But do we have to like do the proof? You don't have to do that for this section, do we?
No, you don't, but it's sort of like a proof because you have to explain what theorem you used, right?
But you don't have to do the whole table and.
All right, yeah, you do not.
Is there
You do.
like 180-degree theorem? Like,
Yeah, it's called supplement theorem. Supplementary angles. All right, guys, that's up to you. Go figure this out. I want to see what you guys come up with.
What is that? What is that angle? Is it one?
What triangle?
Is it?
Oh. Oh, that's measure of angle 1.
is that
That's
what
the
it is?
hyperextended.
Okay, where's
Yes, that is an 8. That's not a.
No, no,
That's
like on the thing.
You're right. It's
Oh.
I brought it with me.
Oh yeah, sorry. So this is 1, 2, 3, 4, 5, 6, 7, 8. This just tells you how arbitrary numbering is. I can go this way. I can go this way. I can do whatever I want.
So through supplementary, 2x equal to 95. And then through complementary, angle 2 is
84 or 85?
We're so
Okay.
if so that measure 1.
And then you do
Yeah.
180.
Well, 1 and 4 are equal because one and 4. No, they're not. You're right. Sorry, I thought.
Wait, if we
4 was
wanted to say the
backwards.
supplementary angle thing, do we just put like what this is?
And 7 are equal.
So like
to
what's 180 minus
Corresponding.
90?
180. Oh, I'm sorry.
95.
95?
Yep.
Okay. So for the supplementary thing with the 180, do you just put like
You have to write
measure
that.
2?
So you'd say the measure of angle 1 or 8 plus the measure of angle 2 is equal to
Oh,
how many degrees? And then how would we explain that? So use your cheat sheet to explain.
Wouldn't that be the angle addition postulate?
Pull it out and see what it says. So guys, when you guys are making this argument, make it a compelling argument, you have to use the right.
We had it last.
4 is equal
No, no,
to
no, you're right.
95.
Here.
180 minus 85.
So wait, so 7 and 4.
Because I was gonna say
That should be in a somewhere in 5-4.
okay, yeah. It should be 95.
Because you're
This
at
is
a
85.
I'm pretty sure it's supplementary.
So what I would do next would be 80. So I would substitute in sorry.
Oh, substitute.
So put in 85 here.
I feel like supplementary
Plus,
means like
you
it
don't
has
know
to be on
what
the same like
measure
line.
it
It
is.
can't cross the line. So we could do 1 and 3
That's
for vertical.
so once you figure that out, write in like small here what the.
I know 3 and 4
That's
are
substitution.
supplementary. I know.
Well, did we find out this one? If you add 2 linear angles
see what I'm doing, right?
on the same line, they add. So give me 5 dash. It looks like it's angle addition, but it doesn't say anything about maybe adding a 200. What does say if you have 2 angles on one line? So you say the supplementary. Do you see what I mean?
Yeah.
You gotta write one. But you just love it.
Yeah, I know.
No, it's okay. You don't have to lie. You can be like, no, I don't.
Okay.
This
I
stinks.
was like, I'm wrong. I wrote
Dang it! Yes. Forgot.
There.
Yes.
Okay.
All right. Sorry.
So then you
This is in degrees. This is in degrees. Very, very good. Yes, you are absolutely correct.
Oh yeah. So two and four.
Okay, so 1 and
No, I
4.
think you have to write because you're still writing about measuring those. I think you have
Do
to
we
write
have to find
No.
what X is?
I think
What is corresponding to 1? I would say 2 is corresponding to 4. But who is corresponding?
So that's 95 and 112.
Yeah, because 1 and 4 is 95 minus 17.
Hold on. So 1 is corresponds to who? 1. Yes, 7. You can do that. It's corresponding. You can build a.
I think you have to write though that 2 and 4 are corresponding. Like
What's it? They're nothing to each other. But not right now. Nothing that we've learned so far. But let's go off of 7. So if 1 is congruent to 7, then what can we say about the measure? So if we're talking about measures, I know I'm very technical. Measure of angle 1 is equal to measure of angle 7. What does that make? Measure of angle 7. Look back at what was given to you. Oh, not angles. No, now we're not comparing angles. We're looking at how much is equal to. You said angle. So let's just write that down. 85 is equal to the measure of angle.
That's substitution.
Good.
I don't think that's right. Because if measuring
Okay,
over
now let's.
95,
Since you made that conclusion,
you would add 7.
what would you say 7 is to 4? Well, just look at it. Are they? What is it? Alternate exterior? Are they corresponding? Are they on the same line? If they're on the same line, how many degrees are they supposed to add up to? Okay, so
We're
what
gonna
do we
divide it by 2.
say? What do we call angles that add up to?
56.
Yeah, and if you look at your 5-4, go back to 5-4.
You don't have to write it in different outlines. I mean, we got the answer
The
already.
supplement theorem says that if you have two angles that are on a straight line, they will add up to 180. So let's do measure of angle 7 plus the measure of angle 4.
So it's gonna get hotter and like you should use the weatherman. And she's always right.
Oh, they're equal to supplement theorem. Okay.
Yeah, so the cheat sheet's a little bit. I think I have to get tested.
And now you actually set up a nice
I
problem. So
have pencils.
the measure of angle 7 is 85. Why don't you substitute that in for 85? What about the measure of angle 4? Do we have anything? That's that is. What did you do to substitute in those values? Okay. I would combine like terms too. Right, and that falls under substitution as well. So a lot of you guys came up with a lot of compelling and different ways to solve this. I actually am really fond that you guys came up with this. I am quite fond of this. Oh, dear. All right.
She got
Oh, so it's yes. That is correct, yes. Because you're subtracting 2x minus 7 to the whole, so that would make it like a distributive. I'm gonna put it I don't even know what to do.
Not much.
All right, guys, I'm gonna put up. I would love to take credit, but it's not my way. I would love to say, oh, I'm gonna put up my way of doing it, but it's not my way. It's what the book came up with. But you guys came up with a completely different method. Some of you guys came up with a completely different method, and it's fine. But
How did they do it?
to check your answer, their way is verified, meaning they had maybe an editor check their work. So So let's see if your answer matches theirs. Did you get that x was at least equal to 56?
I think they just sort of.
So their part is up here. It's the same exact problem, same exact drawing here. Let's go ahead and freeze this for a second. Did you guys get 56?
That's like the same.
56? You guys got 56?
We just did it.
Did anybody do it a different way?
Yeah.
Well, we did it like the first way, but when it got to like the equation, we did it differently.
Okay, so let's see what you guys did here. Okay, so we got, you said the measure of angle 1 and 2 are 180. This already looks different, but yeah, maybe it's saying the same thing. So you guys used that this is a supplementary angle. Then you knew that measure of angle 1 was given to you as 85. So you substituted 85. That's really good. Then you subtracted 85 from both sides. What would that be called, that step, when you subtract 85? It's just subtraction. So, or, to be more perfect, the subtraction property of equality.
Love that side.
Why did you suddenly turn British with it? Yeah.
Huh?
Are all properties of equality British?
They are now. No, I'm just kidding.
No, yes they are.
No, yes, they are. And then you said, to top it off, the measure of angle 2 is, so when you're doing this, I know I'm going to get really technical with you. The measure of angle 2 is only congruent, not the measures, okay? Just the angles themselves are corresponding. No, but they're perfectly fine. That's corresponding angles, posture. 2 and 4, you look at the drawing, 2 and 4 are corresponding. But then, because they're congruent, their measures are equal to each other. Don't you love how technical this gets?
No.
Was that sarcasm?
No, that was an honest question. You love it? You love it? No. That was really good. You achieved that in about 5 steps. That is a very efficient method that you came up with. Okay. So this tells you, is the book the only way to solve these problems?
No.
So when you're checking your answers, okay, as long as your final answer does come out about the same, chances are your method was correct. There's only a few technical things that you don't have someone like myself that has a little bit more experience than you do to go by and check to see if you got it right. Okay, so there's no one way to solve for these problems, right? In fact, CISO came up with a completely different way. I think you got it in about 8 to 9 steps, which isn't bad. It just makes it really cool. Okay? Sophia, how many did you get? Yeah, how many? Sorry, I just called you Sophia.
So. I skipped steps, so technically 8.
8 steps. Okay. Anybody else did? So, Katrina, you did it. How many steps did you get it?
We got it in 6.
6? Huh?
8.
8. Okay, really good. Okay, very, very good. Okay. All right, let's move on now to, I guess that's about it. I was going to go over some other stuff, so just be prepared. There will be more insane problems, such as such as this one here. You have to make relationships between all the angles. I'm just kidding. Okay, sorry about that. Okay. Where are the 2 parallel lines? Wait, you guys can't even see it. I'm just laughing at myself. now you see what I'm laughing.
I just like.
Okay, where are the 2 parallel lines? Where would you think the 2 parallel lines are? We're getting mixed up here. Dr. Hibbert, what are you pointing?
The ones with the pink line.
How does it help? That was too.
There's answers. The pink line.
Yes, okay.
It's just pink triangle.
Just stand again. What is the pink
The
triangle?
pink triangle.
So, does anybody know what the pink triangle is? Not congruency. They are parallel. Okay. What would we call these lines that are intersecting these parallel lines or hitting these parallel lines? So we're only used to having one transverse,
Now we have 2.
but like you were saying, no, for the situation just got. We have 2 trans.
It's
We have
transverse.
it's transverse side. Okay. I don't know if that's a.
It helps.
But just be very careful. That means we have many things going on here. We have, I don't know, we have things that overlap. We got many corresponding angles that relate to each other. We have 14 angles to deal with here, but we're not going to have time.
Well,
for
if you
this.
think about it, the bottom two are like similar, and if you look at the top, then wouldn't it just be 2 and 5, 1 and 6? And
Which
3
are
and
similar?
4?
These bottom two sets are similar to each other.
No, up top. I'm talking about the circle of numbers.
The circle of numbers. In what
So
way are
couldn't
they?
you just use like the vertical
They're all
angles? So you could just do 2, 5, 4, 3, and 1, 6.
Okay, and then how do you make relationships between those guys?
Well, you could do something.
5 and 6 may equal angle 12. I don't know. I'm just guessing.
Oh, because this.
They look kind of.
So this
Yeah.
angle here. Oh, what do we call it? This combination of 5 and 6 and angle 12. They are. Wait. They are two sets of parallel lines, and they're cut off. And let's just.
Angle addition?
No, let's just. Oh yeah, we add. Wow, you even went further. Angle addition and add up angle 5 and 6, right? But we would have to kind of pretend that this transversal doesn't exist for 1 second. What do we call this weird 5 and 6 angle in 12? They're corresponding, okay? So you got to be able to kind of like sometimes make one transversal disappear in your eyes.
It's because there's a second
There's a second transversal, which kind of just throws your mind. But okay. All right, we're gonna stop, or else I know.
Well, then put it 10.
Stop it. We should. Okay. We don't want to get carried away because it's gonna take up more time from doing 5.6, which I'm really good at. We're not. We're not. Huh?
Yeah, we don't have a cheat sheet for 5.6.
Oh, snickerdoodle.
Sure, it's secret. Yeah, stop talking about food.
Oh, pizza. I'm just kidding.
That's not nice.
All right,
First
this.
it smelled like food, now we're talking about
Oh
food.
yes.
We love food.
We love the food.
I
Love
know,
them.
but I'm hungry. This isn't healthy.
We love them foods. Okay. So I don't know if I forgot to print out a cheat sheet or if I even made one.
There's no 5.6.
There is no 5.6 cheat sheet at this point.
Will you make one?
I don't know.
Can you make one?
Okay. I will try to make one. Then. Yes.
Make sure before the test that keep it in your backpack or your bag.
Yeah, make sure 2 of those so you're not just like,
All right. Here's the deal. I will try to make one, but it is your best interest to make your own in case I forget to bring them. Okay. I don't think no promises. I don't think I'll have a problem making them. It's whether I'm gonna bring them or not. Okay. Because if
But I thought you said you
Everyone just
couldn't
email
write on
Mr.
them.
Wee every day.
Huh?
To tell him to bring it.
yeah. Oh,
Email
okay.
you every day to tell you to bring it.
Post it on Google Classroom after you make it, and we can print out right now.
Again, the memory is wavering with this one as the fourth.
We can just like spam you.
Let's all just
send them on reminder.
I have 180
5.6.
emails. I have 180 emails telling me to make a cheat sheet.
Resend.
Didn't we just learn this by the way?
Let's hack into your computer and make it ourselves.
What? That's a weird way. It's a weird reason to hack it. I want to hack it just so he can make the proper cheat sheet for me to do well on the test.
Hey, that's actually
It's a weird, dishonest, honest move. I just want to do really good in this test, even though this test could be indicated. Okay. This looks just like what we learned before. What the heck is the difference between this and corresponding angles quotient? The one what we learned about was literally just called the corresponding angles quotient. This is called the converse of the corresponding angles quotient. Read over that and then maybe read 5.5. What the heck's the difference? I don't see any difference.
well, parallel lines have
Oh, parallel lines are A and B. Okay, yes. They are called A and B. Okay, I agree.
In the last one we learned about, we knew that the lines were parallel and therefore the angles were corresponding, but now we just know that the angles are corresponding, so therefore the lines are parallel.
Oh, so this is different. Very nicely done. Okay, this whole chapter is the converse of everything you just learned from the previous chapter. But what does that mean? That means this. Your lines A and B were never given to you as being parallel. You don't know.
But you can tell.
But you can tell. How would you be able to tell that? Because it looks, but you can't go by the looks, right? You gotta kind of find it by the substance here. Meaning, you would have to painstakingly measure. What's the measure of angle? Oh, actually, it's kind of cool. I don't think you guys care, but I'm like, oh wow, actually, it's cool. It projects right on top of it. It's like 140 degrees. Okay, so 140 degrees. Then I'm like, you know what? These lines look about parallel, so I'm just gonna check them real quick. 140 degrees. Ooh, I'm gonna say 1 and 3 are corresponding. Then I'll be like, oh, let's check this one. That's about a. Oh.
What if it wasn't parallel? What if we made a mistake?
Okay, so this is about 50. No, this is. Make this up. This is about 50. That is about 50. So they're corresponding, and then if you determine they're all corresponding in some way, like 1 to 3, 2 to 4, 7 and 5, 8 to 6, then we could successfully say A and B are parallel. Do we have a hand up here? No, I'm just going local. Okay. And then we have a whole thing over here.
So if there's that much, then we do need a cheat sheet.
Yeah, I mean, well, as long as you understand one cheat sheet.
Write on the book?
No. That looks like my handwriting. All right, so yeah, pretty much everything that you learned about looks exactly the same, only it's kind of inverse. So in this case, if you determine the alternate interior angles are actually congruent to each other.
So they're the exact same, just backwards.
Sure. Yes. Yeah. No, not sure. Yes, they are. That's exactly it. Okay. Not just a sure. Yeah. Why not?
Sure, why not?
Yeah. Yeah. Sure. Why not?
If you believe.
Okay. All right. So that being said, that's kind of everything that we know. But let me see if I can.
That's a nice view.
Wow, I'm learning so much.
Okay.
Mind-boggling, guys.
What problems I have planned for you guys here? Oh, wow.
No, it loses its effect when you don't actually have class.
Yeah, wow. There you go. Do I want to do that? Yes. Huh?
You need braces.
How does this work?
I know. Like, it's recording now.
Well, yeah, it is. So people are gonna be like, "What am I looking at wires for?" He's going off the deep end.
That's not funny.
I don't
It
get it.
happens, like,
Same.
I know.
Today?
Braces are just awful.
Honestly, you get used to it. So.
I know you do, but it doesn't make it better. It
I
just,
have
like,
one
make-
year left.
I've had these on for 2 years, and they're like, only a year left. I'm like,
Okay.
they've said that like 3 times though.
Here's an exercise. I guess let me see. Alternate interior
They
angles.
better not.
They can.
Sorry, I'm just trying to look ahead about what I want you guys to do.
For the rest of your life, you have to wear rotating.
I know. Like, what is that?
Does it hurt?
Okay.
My teeth weren't even that bad. I would have been fine without those.
Okay, so this is what we're gonna work on here.
Otherwise,
Yeah,
seriously, if you
just
don't
like
wear
I lost all my
tiny
teeth.
Yeah, because they're so used to you like misplace them for what they were already, so they're gonna repeat that. Yeah, braces, right? Because they don't wear retainers, so then it
I'm
gets.
still missing one of my 12-year-old molars. The other two have come in, but this one's like white.
That's the thing though, like after three, I think some people are saying that like they don't wear the retainer for 3 days or they put it back on and have it.
All right, guys, go ahead and write this down. Proving lines are parallel.
Are you sure it's 5, 6?
Yes, it is.
You're sure?
Oh, I'm sure.
Are you sure?
Oh yeah. Yes,
Are
I
you sure that that's the title?
maybe. You're casting doubt in me, which makes me.
That's my job. You're welcome.
You're the doubt caster.
I can never spell parallel right.
No,
I can never
I'm just-
remember where
I'm
the
the
two
devil's
are.
advocate. I have to make sure that both sides are.
Fair enough. Okay. Identifying parallel lines. I'm gonna give you an example. Given the following information, determine which lines, if any, are parallel. I'm going to take a little abbreviated shortcut there. So that means parallel, okay? Or maybe two straight lines that are bigger than the L's printed in your book. Then you must state the postulate. So remember, this whole point of this chapter, last chapter is when things are parallel, what happens? This chapter is the inverse. Can you prove the lines are parallel? Okay, so this is a little bit backwards. Like Luciana was saying, it's a little backwards. That
Are those two lines in parallel?
yes, it does. It justifies your answer. Okay. So you have a choice in drawing this or not, but I am going to give you this problem. Actually, yeah, you know what? Let's do that because you need something to take home in your notes here.
So we have to draw.
Yes. I'm sorry. Yes, you do. Yes. Absolutely. Yes.
Well then, can you draw it so we know to draw?
Okay. This looks ambiguously parallel, but we don't know if they are. These look ambiguously parallel, but we don't know if they are. Okay. I'm gonna number that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15, and 16. Okay. Hey, but are any of these vertical? Any of these angles vertical at least to each other? Yeah, so just keep that in mind. Vertical angles are not, confined to arguing about parallel lines, okay? If they're vertical, they're vertical. But that's not what I'm trying to get at right now. What I'm trying to get at is this. Let's go for A. Let's say here is a statement right here. So let's say, given the following information is going to be like this. Here's following information that's given. Angle 2 is congruent to angle 3. And then let's say that angle 3 is congruent to angle 11. Okay? If angle 2 is congruent to angle 3, angle 8. I'm sorry. I wrote that wrong. If angle 2 is congruent to angle 8, and I should name these. Sorry. This is line L, M, A, and B. If angle 2 is congruent to angle 8, which two lines am I proving are parallel to each other? Is it A, B, L, or M? Which lines are parallel to each other? This is pretty tough. If angle 2 and 8 are congruent.
2 and 8, not.
Yeah, 2 and 8. Sorry, not 2 and 3, but 2 and 8.
2 is congruent to line M. Wait. No, line A. Wait.
Go ahead. What do you think?
The line A is congruent to line M.
Or line A is
Equal. Oh, parallel.
parallel to line.
Oh.
I'm sorry. So do you guys see the two lines that are parallel? Because 2 and 8 are congruent to each other, who would be the transversal there? Just out of curiosity. L is a transversal. However, what postulate or theorem am I saying that 2 and 8? What connects that if these two are parallel or these two are congruent, that makes these lines parallel? Angles. Not just the alternate interior angles, though. It's the converse. It's saying that if these two angles are congruent, now it makes these lines parallel. Does that make sense? So we'd say converse of the alternate interior angles theorem. I'm going to say AIA. How about 3 and 11? What if 3 and 11 were now congruent? What two lines are now parallel? This is tricky. Yeah. L and M are parallel to each other. Who's a transversal, Ivory? A is a transversal, and then what links 3 and 11 together to make them congruent, and then ultimately make L and M parallel?
Corresponding?
Yeah, so it'd be converse of the corresponding. All right, I'm gonna give you the rest. Oh, how much time do we have? Are you guys about leaving?
1 minute.
Okay, all right, guys. So I guess I'll create the rest of this video right now, okay? And you guys can take off right now, okay? Thank you guys so much for joining. Please put away your chairs, and you guys have a wonderful day. Be careful of the rain. Right? There is no rain.
Is it not rain?
Oh, it was a pasta with
Chicken and
well, hey. Okay, yeah. It was.
vegetables.
You stole my thunder, and you stole my rain. I'm just kidding. All right. And the lightning. But you didn't take away my puzzle. All right, guys. You guys have a wonderful day. Turn on the lights. Oh, in my hand.
Envelope is right here.
Oh, thank you, Katrina. All right. So you guys still have the protractor? No. Thank you. Oh, yeah, now it's back in my hand. After 29 years of travel, Dr. Everett, it's back in my hand. But immediately, what is up? I don't know. Oh, it's not
French
just.
curve.
That's
Circle
actually,
gauge.
a lot of the time that's
Yeah.
actually used for dogs.
Really?
Yeah.
The French curve?
Well, people use things like this.
There it goes for real.
Like this is actually
I love
used
it
for interior designing.
They're so cute.
Yeah, because you can get the curves of furniture, you can get the angles
So
for
good.
doorways. My mom's an interior designer, so.
Wow, you really know. That's
What is it? It kind of looks like a snail.
yeah, it's a French curve.
Oh.
Get it right.
It's still used in it's still used in math a lot, but like
Yeah.
it can be used for interior designing when they're putting out layouts for floors and complexes.
That is very interesting. I did not know that.
Mr. Bruce, I'm coming to take my test at 12:30.
Okay, that is correct.
Yeah. Okay.
Month 4 or month 3 or month 2? Are you retaking the exam? Or?
Yeah.
Okay, you are. Okay.
Yeah.
It'll probably be month 1, 2, or 3. It's probably gonna be
It was so I'm
taking month 2's exam.
well, I did corrections for month 1 and month 2.
Okay, so you
So
took
I'm
both?
taking
That's
either
right.
one.
I saw your email. It did say
Yeah.
that. I just wanted to
Either-
try to take 2. Okay.
Yeah. Okay.
I will see you soon, Catherine.